Double-Slit experiment and the future of the space technology. This video is part of a series of videos describing the entire universe. I am starting from the early stages of the universe before the Big Bang. I am discussing the various situations for the formation of the Big Bang Singularity. Then the cause of Big Bang at that particular time is also explaining here. In this video series, I discuss the subsequent Big Bang, the expansion, the structure, and the end of the universe. I illustrate all this with the help of a new concept that I have developed from my studies. In this video, I wish to discuss some of the major issues that are bothering me. First of all, why did the Big Bang happen at that particular time? Another is the Baryon Asymmetry problem. It is that after the Big Bang, instead of the particles and antiparticles having to be created at the same amount, why did the particles have become more numerous? Another is why particles can exhibit both particle and wave properties at the same time. Let us see how can I explain it all with the help of a simple idea. From this idea, we can get the answers of lot of questions that we are looking for like this. If we place this idea into the space technology, we can achieve a very huge velocity to the spaceships. Our universe is a storehouse of wonders. This vast universe of ours, the tiny particles within it, their fundamental features, the very large stars, and their formation process all amaze us. And the functioning of our universe, like the stars, their planets, their subplanets, the atoms, the particles within it, and their features all are wonderful. We will be amazed again when we realize that all these things are the result of a process that we call the Big Bang. There is only one reason for all these miraculous phenomena. It also provides us answers to many of the questions we seek. Let us start with the first problem. Why did the Big Bang happen at that particular time? We know that the Big Bang Singularity had the energy to encompass the entire universe what we see today. If more than a certain amount of energy is concentrated in one place, it is possible for to be born a new star over there. But we are not talking about its causes here. Then even though the energy contained in the whole universe was concentrated in one place, why did the Big Bang not happen earlier? Or why didn't the Big Bang happen a little bit later? So that it can store some more energy into the singularity. In any case, I do not believe that the Big Bang singularity was formed by the intervention of a god and that the Big Bang happened. I understand energy and space as the only two fundamental building blocks of the universe. All other phenomena what we see in the universe are the result of the interactions between them. To understand the universe, we must first understand how energy exists in the space-time. Space is just as important as energy. Space is essential for energy to stay. Therefore, a certain amount of energy will keep an influence on a certain amount of space proportional to it. But if the situation is like this, the universe will be in a balanced state. If the primordial universe were in such a state of equilibrium, not even the Big Bang singularity would have formed. So there must be an unbalanced situation in the primordial universe. That's why in the primordial universe, the amount of the space or the energy must have been greater than any one of these two. If the amount of space or energy is little more or less, it will create an imbalance over there. It was this imbalance that led to the formation of the Big Bang singularity. This is one of the main reasons for the subsequent Big Bang. Already we know many other reasons to encourage the Big Bang to happen, like the density, pressure, temperature, and many other situations in that period in the singularity. Here we are looking for the reason to happen the Big Bang at that particular time. So the interaction between space and energy is important for this situation. It was this imbalance that created the favorable conditions for the Big Bang to happen at that particular time. The Big Bang happened only when the imbalance between energy and space reached at a certain ratio. All these situations are well described in my book, The Key to the Secrets of the Universe. You can see the evolution of the universe from the primordial stage until the destiny of the expansion of the universe in my book. There you can see a lot of new ideas on the expansion and the acceleration of the universe and about the gravitational interaction. I am explaining there how the expansion of the universe is undergoing another Big Bang. You can find the link to the book in the description box. Now we will see why did the particles become more numerous. We generally call this as Barium Asymmetry problem. After the Big Bang, the particles were created in pairs, like particles and antiparticles. These are so contradictory in nature that they collide with each other and will be destroyed. This is one of the unsolved problems in physics. We call this as baryon annihilation or matter-antimatter annihilation. If the things are going like this way, then the universe what we see today would never be formed. But the whole universe is made up of matter. For this to happen, there must be more particles than antiparticles. If the Big Bang took place in a state of equilibrium between space and energy, this state of affairs like baryon asymmetry would not have been erased. Let us consider this singularity and its native spacetime as a closed system. In an equilibrium system, particles always created in pairs. An imbalance in the ratio between energy and space can create an imbalance in the ratio between the formation of particles and antiparticles. But we cannot see this as a large scale imbalance. In the early universe, the difference between particle pairs and free particles are very small. We can see this difference in the period of origin of the particles after the Big Bang. An independent particle created only when there about 1 billion pairs of particles were created. Therefore, it can be seen that the difference in the ratio of space to energy in the universe is very small. This difference is the main reason why the Big Bang can happen at that particular time. Now we will check how particles can exhibit both particle and wave properties at the same time. Earlier we thought that light had only a particle nature, but later we learned that light exhibits particle properties as well as wave properties. We proved it through the double-slit experiment. But the problem that bothers me is why light exhibits all these two qualities. This will not happen without a fundamental reason. I strongly believe that it is because of the two kinds of motions of light or particles. To learn more about these two different types of motion, let us first examine the structure of the solar system in detail. We know that Sun is the center of the solar system. Planets and other objects in the solar system are orbiting the Sun. So it can be said that all these are within the space-time of the Sun. We can take the Sun and Earth as examples to understand in more detail. The Sun has a space-time proportional to its mass. According to general theory of relativity, the Earth is located within the curved space-time of Sun. Naturally, Earth can also create a curved space-time proportional to its mass. Although the Earth is located within the Sun's space-time, the Earth is creating its own space-time over there. Now we can see two different space-times within a system. This is how Moon creates another space-time within Earth's space-time. Although within the space-time of the Sun, the Earth's space-time is independent. Earth's space-time has all the characteristics of the Sun's space-time. That's why the Moon can create another space-time within the Earth's space-time. Now we met three different space-times within a single system. Now let us see how they move. As the Earth orbits the Sun, the space-time with it also accompanies it. Otherwise, the Moon, which is located within the Earth's space-time, could not remain there. Here we can see that the space-time is also moving according to the motion of the mass. Now let us look another type of motion. Suppose we are throwing a stone into a pool of water. The stone will sink into the water soon by making waves on the surface of the water. Here we cannot see a motion like the one seen in the solar system. When the stone is submerged in the water, it leaves its own space-time on the surface of the water. The space-time is added to the Earth's space-time. Whenever the stone is taken out of the water, the space-time will be added to again. If we examine here in detail, we can say that there is only time with that stone. The space is being removed. The space is added to the Earth's space-time. It is happening like this because the characteristics of the water and the space-time are different. So let us see what happens when an object moves from one space-time to another with the same properties. For that, we can observe the motion of a photon. Suppose a photon enters the Earth's space-time from within the Sun's space-time. That photon is capable of two kinds of motions. It can travel through the Earth's space-time while keeping its space-time with it, like the motion of the Moon within the space-time of Earth. Similarly, a photon can move freely by attaching its space to Earth's space-time. Later, when it goes beyond the Earth's spacetime, it can regain its own spacetime. We can see these two types of the movements in the double-slit experiment. While the detector is active, it may add its spacetime to the Earth's spacetime. In all of our motions, we are carrying spacetime with us. Even our spaceships are following these types of motion. So we need to find a way to add the object spacetime to the parenting spacetime. If we can use this possibility in space travel technology, we will have a revolutionary breakthrough. If we can understand how energy and spacetime interact, that is the key to the mysteries of the universe.